Welcome to the IM2 video lecture. This is going to be covering characteristics of a function part 1. The learning target is for you to understand the different characteristics of a function. There are 3 success criteria. 1, I can find the x and y-intercept of a function. 2, I can locate the vertex and determine if it's a minimum or maximum. And 3, I can find the line of symmetry and the interval of increasing and decreasing. First of all, let's review the domain, range, and end behavior. When we are looking at the domain, we look from the left to right, and we see from left, it is negative infinity all the way to positive infinity. So we can write the domain as from negative infinity, comma, to infinity. And please understand that the parentheses are because it's open. Okay, it's open on infinity. Let's look at the range. The range, we go up and down. We saw that the lowest value it ever hits here, it's the value of -3. Then it goes all the way to positive infinity. So the range would be close. It's closed at -3, and it's open here at infinity. The reason why it's closed here at -3 is because it touches the -3. Next, let's talk about the end behavior. The end behavior can be described as the left arm and the right arm. Let's look at the left arm first. This is considered to be the left arm. And the left arm, by definition, is when x goes to negative infinity. Because that's the left side of the parentheses of the x value. Do you see? Left arm is right here. Okay. The right arm is this. Right arm. And we saw that the right arm goes when x goes to infinity. So that's where you're going to get these values. Now you all have to see if it turns up or turns down. We saw that the left arm here, it goes up. So here you can say up. So this is when y goes to what? Goes to infinity, because that's the up. Right? So the left arm, x arrow negative infinity, y goes up, so y arrows infinity. If you look at the right arm, okay, we saw that that also goes up, so y arrow goes to positive infinity. Same thing here. Okay, so these are the definitions of the left arm and the right arm. This never changes in the question. The only thing that changes is the y, if the y goes up or down, but the left arm and the right arm never changes. Let's explore some characteristics of the function that we just worked with. So these are the special points. The y-intercept is where the function passes through the y-axis. So that is where it passes through the y-axis. And we call that the y-intercept. It's always in the format of parentheses, 0, comma, y. The 0 here is because x is equal to 0 here. The y-intercept for a parabola, there are 2 points. For this one, it's -1, comma, 0, and the other one is 3, comma, 0. The format of all y-intercept is the number goes first, comma, 0. Notice here, the y's are both zeros for the y-intercept. Here's the visualization for you to understand. Copy down the core concept if you need it. Now we're going to practice to find the x and y-intercept of this function. Let's take a look. The first one, the y-intercept, is where the graph crosses the y-axis. The y-axis is in the middle. We saw that the x-intercept is, the y-intercept is 0, comma, 2. The y-intercept, there are 2 points. The first one is -1, comma, 0. And the second one is 1, comma, 0. These are your 2 x-intercepts. let's do an exploration here. What do you notice is the difference between number 1 and number 2? So you can do what I notice and what I wonder. Some things that you should notice is this. Number 1, you see that it starts by decreasing, hits a lowest value, which we're going to call the minimum, then it's going to go back up again, which is increasing. So the minimum is referred to the lowest point. For number 2, it actually starts increasing first. It hits the maximum, then it goes down by decreasing. That is the maximum, and we call that the highest point of the graph. The minimum and maximum is also called the vertex. So the vertex of a quadratic here is either the highest or the lowest point of the graph. Because it is a parabola, there's only one vertex. Okay? Because it's a parabola or a quadratic equation, there's only one vertex. So you should already have 1 and 2. You've seen this before. All we're going to do now is find the vertex. The first one, it's at the point 1 for the x, if you want to see, right? This is 1 for the x. Then it goes down here to -3. So this point is 1, -3. The vertex here is a minimum at that point 1, -3, because this is the lowest point. Number 2, it is the point 0, 2, and this is going to be the highest point. Therefore, we call that the maximum. Now, if we take a look, there's this red line that we have for both of them. That has a special name. That is called the line of symmetry. It is the equation that separates the function in half equally. So notice that the left-hand side and the right-hand side of either function are the same. So, if we take a look, the line of symmetry here cuts this right in the middle, and we write the line of symmetry is equals to x equals to 1. Why? Because, take a look, this is this value here. Because this is the x value. Remember, a point is x comma y. Same thing here. This is going to be the x value. There you go. Okay. The line of symmetry is the x value of the vertex, because that will always split it in half. It splits it in the vertex. So the line of symmetry always crosses the vertex. Now, when it splits it, okay, look, if we split it, it splits an increasing side and a decreasing side. So let's take a look for this one, right? This splits it. This side is going to be decreasing. So this is your decreasing, because it gets smaller, goes to the minimum, then it increases. Then here it goes up, so that is increasing. Then it hits the maximum, then it decreases. So the interval from increasing, it goes all the way from -infinity all the way here. It stops here at the 1. And this is going to be for decreasing. Okay. You should see that. Do you see how it goes from here, from -infinity all the way here to 1? So this is decrease. Then, let me change colors to orange. It starts increasing from 1. So from 1, it goes all the way to +infinity. That is where it's increasing. All right. Please understand that we open it both at 1s, because you do not know if 1 at the point 1, it's either increasing or decreasing. Same thing here, but let's do increasing. Let's do decreasing first. So the decreasing interval, okay, it goes from here, from what value is this? I think this is from the value 0 all the way to +infinity. So that's where it's increasing. No, this is where it's decreasing. So it's getting smaller. You see how it's going down? Then we have our increasing, which is, I'm going to make in this color. we saw it's increasing from negative infinity all the way to 0. Okay, so it is increasing from that interval. All right, that's the unique part of a parabola. All right, so there you go. That's all you need to know how to do to find the characteristics of a function.